The forests of Puerto Rico are always changing. Following Hurricane Maria, they've changed a lot. But by taking measurements on the ground, in the air, and from space, we're able to not only identify those changes, but also follow them through time as these landscapes recover the lush tropical forest they had before the storm.
NASA scientists were in Puerto Rico in early 2017, studying how forests grow and change. They returned in 2018 to assess the forest recovery after 2 hurricanes hit the island.
In many ways, Hurricane Maria has reset patches of forest across the island. Canopy trees normally have a large and sometimes circular crown, allowing them to spread their leaves, photosynthesize, and live in the top of canopy. Hurricane Maria came through and ripped off many of those large branches, leaving individuals standing almost like an individual stem. What that means is that they'll have to regrow those leaves or give up that space in the canopy to their neighbors as they regrow beneath them.
The team returned to the specific plots they measured the previous year, hiking through the thick underbrush that had grown since the hurricane opened up the canopy.
A bit like this, Ian. When this large tree fell, it took out most of its neighbors and created a large gap in the forest where sunlight will now reach all the way down to the forest floor. That'll allow new, young trees to grow back in its place. In contrast, on this side of the plot, many of the large trees were stripped of their large branches, but they're still standing, and most of them will recover those leaves and grow back into the space they left behind.
But with forests covering half of the island, walking up to every tree was not practical.
So my name is Bruce Cook. I'm from NASA Goddard Space Flight Center. I'm here today in Puerto Rico assessing damage that was caused by both Hurricane Irma and Maria. And we're doing it with this instrument to my right, which is called G-LIGHT. G-LIGHT stands for Goddard's LiDAR, Hyperspectral, and Thermal Instrument. And it's using multiple sensors to actually understand more about terrestrial ecosystems.
G-LIGHT is installed on a small airplane and flown at low altitudes to collect lots of measurements in one pass.
The LiDAR is being used to measure changes in the structure of the forest canopy, how many branches were lost, how many trees were knocked over. But we're also using other sensors that measure things such as how much or what changes in the amount of sunlight that's being absorbed by these canopies and how that's affecting their photosynthesis and growth these days.
The LiDAR sends out 500,000 laser pulses each second and can detect the physical structure of individual trees.
That laser energy from our LiDAR systems will intercept the top of canopy, smaller branches on the way down, and all the way down to this understory vegetation in the ground to help us construct a three-dimensional model of these forests.
But even though G-LIGHT collects several types of data, it's not enough to fully understand how forests react to changes. Measurements from the ground level are a necessary complement.
The same laser technology on G-LIGHT can be put on a tripod on the ground to make very detailed measurements of individual trees, the vines and lianas that hang from those trees, as well as the damage that's occurred.
So this is a partnership and it involves both the data from the ground, but also the data from the airborne instrument, as well as data from the satellites. So we call this scaling, when we can scale for ground measurements all the way up to satellites, and it just helps us understand what's going on in the larger picture.
By being able to take information about the changes and the recovery of these landscapes over time, we're able to connect the changes in the carbon cycle, the changes in tropical forests and their functioning, even the changes in the strength and intensity of hurricanes, and understand how those changes observed today help us understand and predict tomorrow's changes, as well as the imprint of that hurricane in our atmosphere worldwide.